Hey everyone, welcome to this video, and today I'm going to walk you through everything that you need to build your own AI agents. So we'll start by understanding what an agent is, connect it to external tools. Then we are going to briefly understand what MCP are and how they are replacing traditional tool calling and standardizing the way how agents and AI application interact with external world. Once that is done, once we understand what MCP is, we are going to use an MCP server and connect it to our local agents. Once that is done, we are also going to add a custom memory layer to our agent so that our agents can have a human-like memory and they can start thinking like humans. And in order to do that as well, we are going to use a 100% open source tool, and we'll also leverage MCP to connect this memory to our agent. Finally, once all of this is done, we are going to make sure that we add monitoring and observability to our AI application so that we can trace and observe everything that is happening in our pipeline, again using another open source tool. And all of this would be done in a step-by-step way with illustrations and code examples. And I'm going to share all of this code with you at the end of this video. All right, so let's get started. So what is an AI agent? So an AI agent is something that can use LLM as its brain to reason. It has memory so that it can remember the context or whatever conversation that we have with it. It also has access to tools so that it can, interact with the external world, like sending an email, fetching weather reports, or doing web search and stuff like that. So in short, it thinks, it remembers, and it can take actions. So if you are able to build something like this, that means you already have an agent. So in order to build everything that we just discussed today, like agent, connecting it to tools, connecting it to MCP server, as well as a custom memory layer, we are going to use 100% open source tools. So we'll start by importing CrewAI, so which is going to be a library that we are going to use to build agents, plus orchestrate the multi-agent system that we are going to build. So first of all, we need to set up a local LLM. So as I said that all the agents that we are going to build will be running locally, we'll connect them to tools, we'll connect them to MCP server, and all of the data is going to stay on our machine itself. So first we are going to start by defining a very simple agent. So it's just a QA assistant. So it is going to use an LLM, and based on the knowledge that the LLM already has, it is going to provide us the answers, right? So it does not have any access to tools or MCP server. So this is going to be our first step, right? So it's a virtual assistant. What we are going to do is in a CrewAI, typically you need to specify three things: the role, goal, and backstory. So we are specifying that you are a virtual assistant, you help the user with their questions, and the backstory is that you are an agent that can help the user with their queries and questions, right? So all of these things can be easily prompt engineered based on the kind of agent that you're creating, which we are going to see very soon. So once you have an agent defined, you also need to define a task, like what this agent is supposed to do. Again, like it's just a virtual assistant that is helping the user with this query. So we are going to provide this in the description of this task. And we also specify like what agent is taking care of this task, right? So we already have defined this agent. So once you do that, we are going to define a crew wherein we specify all the agents that this crew has and the task that these agents are going to perform, right? So let's do that. All right, so the crew has executed and you can see all the logs, like when the agent started, the task that it is performing, and the final answer that it is generating, right? So we asked it, what is the capital of France? The capital of France is Paris, right? Let's get this out of way. I mean, it's a fairly simple example. I just wanted to show you how a simple QA agent would work. Now we are going to build on top of it. Next, what we are going to do is, we are going to make sure that everything that we are going to do today is monitored and traced. So basically we want to make sure that everything that happens inside our agents or AI application is traced and observed in a particular dashboard. So in order to do this, we'll be using Comet Opik. Again, it's a 100% open source platform that you can use to build evaluation observability or your AI application. And it comes with integration for a bunch of different frameworks. And today we are going to use its CrewAI integration, as you can see here. So all you need to do is to, write this 3 to 4 lines of code, and then Opik takes care of everything, right? So let's run this. And we have created a new project which is called a CrewAI integration demo. And if I go to the dashboard, we have this project here, right? And whatever we are going to ask, so let's try to run this again. And this time we are going to run it with the, what is the capital of, let's say, Spain. So just to give an example, so it says that the capital of Spain is Madrid. So for now, like, it's a fairly simple application, but like, even if you go beyond this and if you try to ask it harder questions also, so here is the trace for what we just did, right? So you can see like what was the input, what is the output that is produced, right? So it is, you're going to soon realize, like, once we add tool calling and MCP server and stuff like that, this observability is going to be very important, and it would really help you to understand what's going inside your application. Plus it will help you debug it as well, right? So let's get back to the notebook. Now that we have a simple agent built, let's try to add a few capabilities to it. So we are going to add web search capability to our agent by providing it access to a tool. And this tool is something that we are going to build using LinkUp. So basically LinkUp is just a platform that provides your agent access to web data, and it has a really nice Python SDK. So here is the code for defining a custom tool that you can add to your Crew agent. So don't get overwhelmed with the number of lines of code that we have here. I'll explain step by step what all of this mean, but it is fairly simple. So for now, you just focus on these 3 to 4 lines, right? So this is the LinkUp SDK code where you define a LinkUp client, right? And once you have this client defined, you are going to, do search or let's say call search method over it, right? And now search takes 2 parameters, the query, in fact 3 parameters, the query that the user provides, like what exactly we want to search over the web, the depth, whether we want to do a standard or deep research. So deep research is just like, Perplexity's deep research or OpenAI's deep research. So it's fairly simple. And then we can also define the output type, whether you want a structured JSON output through it, or you just want a string output. For now, like, we are going to keep it as string, right? So once you understand like what is the core logic or what is the core functionality that is being implemented inside this tool, let's try to understand the structure and how exactly a custom tool is defined, right? So first of all, CrewAI provide this base tool class, and you can use this class to build on top of it, and you can easily define custom tools. So once you create this LinkUp search tool, everything that goes inside the run method is the actual logic or what this tool is supposed to do. So in our case, it is doing web search. So we put this inside this run function, right? And you also need to define the input and output schema for this tool. So this helps our agent or the LLM to understand like what exactly this tool does, what parameters it takes, so that our LLM or our agent can take the user query, parse it in a way so that it can identify all the parameters that are required for this tool calling, right? So we define that that there are going to be 2 input parameters, which is the query, the depth, like whether we want to do standard or deep research, and we also specify the output type. So in our case, like, the output type is just a string, and the output description is like you can just provide some description about the output, like how it should look like and what all it should have and all, right? So once you have defined the schema, it is again using Pydantic. So fairly simple, nothing new here. And then inside your LinkUp search tool, you need to specify the name of the tool, like what exactly it does, the description. So basically adding a bit of verbosity so that it's easier for the LLM to understand like what all this tool can do, and so that it can easily make the right tool call, right? And then you also pass the argument schema that we just defined here. So once you do all of this, it's fairly simple. A tool is just a function that you define in Python, right? But with a bit of structure and schema that you need to add so that it can properly work with our agents. So it's fairly simple. So once we have this tool defined, we are going to do is define a new crew, or let's say define a new agent. So this time our agent is a web search agent, you define its role, goal, and backstory according to what it is supposed to do. So in this case, it is doing web search, and the backstory is you are an agent that can search web for information, right? So fairly simple. And if you notice here, we are also providing it access to a tool, right? So this time it has access to the link up search tool that we just defined. And once you have the agent defined in CrewAI, we also need to define a task. So again, the task is to do web search based on the user query. Now user query is a dynamic parameter that is going to be provided by the user once we kick off this crew, right? So finally, we put this agent and the task inside a crew. We kick it off and we provide the query here, right? So let's modify this query a bit and say that so what I'm asking is, since this agent is able to do web search, it can do, fetch latest result. So currently Wimbledon is going on. So it's basically a tennis championship that is currently going on. And I'm asking my agent to give me a summary of what exactly is happening in this event, right? So let's do that. And it is able to identify like I need to do a tool call to provide answer to this query, and it is doing link up research, link up search as the tool. And finally, you can see like we have got some raw results, and let's see the final answer. So as it says, like, we are able to fetch the latest result, and it says that Wimbledon 2025 is underway at All England Club in London, running from 30th June to July 13th, right? So which is pretty cool. Now our simple agent that we had, it also has access to web results or internet, so that it can, based on the user query, if it cannot directly answer it, it has ability to go to the internet and search for it and provide a comprehensive response to it, right? So which is pretty great. And now once we understand what tool calling is and why it is important, now we are also realizing that, okay, every time, let's say if someone else had to use this tool, so let's say if someone is building their agent in some other framework, or maybe they want to use this tool with the any other application that they are trying to build. So then they would have to change the definition of this tool, right? Because every different framework might have different requirement on how you define the schema, how you structure this, what should be the name of this function, should it be run or should it be execute, and stuff like that. So this is exactly where, the tool space or the way our agents were interacting with the external world was completely scattered until MCP came in, right? So before I jump into this code and go through all of this, what we have done here, we are going to connect this agent to MCP server, and all the tools that are inside that MCP server, we are going to, call them just like a regular tool that we just had, right? But before we do all of this, I want to quickly give you a background of what MCP is and why it is so popular. So what is MCP? So MCP is just like a USB-C port for your AI application that basically standardize how your AI application interact or connect to external world or external tools, right? So before MCP, like the tool space or how your application or agents connected to tools was completely scattered, but MCP standardized it, right? So let's say someone has created an MCP server for GitHub. So I can easily use the same server without changing anything on the server side. I can connect it to a CrewAI agent. I can connect it to my cursor ID, or I can also connect it to any agent or application that has, that is basically adhering to this protocol or that is following the rules of this protocol, right? It's just a simple gRPC message exchange format that it is using, right? So nothing fancy about it, but the way it has simplified, the tool calling space, it has become really powerful. Okay, so LinkedIn only allows me to upload 15 minutes of video. The rest of the video can be watched on my YouTube channel. I've shared the link for the same in the first comment. Thank you so much.